Okay, so a 2-minute review of what we learned yesterday about rational functions. Here is the simplest rational function. A rational function can be written as a fraction. That's why they call this a rational function, because it's a fraction function. And if I had you graph this one, oh Lord, I hope you can do that. Would you give that a shot? And then I'm going to add something to it. I'm going to say, of course it won't be that easy on the test, but what if we had one that threw in this? X plus 4 and x plus 4. Now, make it really clear where that little thing is on your graph. And in a moment, I'm going to have you compare yours with the person sitting next to you. If you don't know, ask them how it goes. Okay? I'll pause for a second while you give that a shot and compare with your neighbor. What does that little thing right here do to the graph?
It puts a hole in the function at -4.
So if the function was going to look like this, then now the function's going to be like that, except over here at 1, 2, 3, -4. What do I do?
Put a hole. Put an open circle.
All right. And that means that at that one little spot, it doesn't work. All right. Now, I trained you how to find asymptotes. Vertical asymptotes were what made the bottom 0. But there's always little exceptions to everything. X equals 0. Is that actually an asymptote? Look at the graph. Is x equals 0 an asymptote? Yeah, it is. Is that a vertical, like up and down kind? Yes, it is. Okay, so the vertical asymptotes come from what makes the bottom 0. But -4 also makes the bottom 0. So why isn't that an asymptote? Because if it has a chance to be an asymptote or a hole, if it's got this, it's even more like complicated. That's a hole, not an asymptote, because you can't be both. Okay, so this one gave us a vertical, sorry, it gave us a hole. Now, one thing I didn't teach you yesterday also was how to find exactly where that hole is. Everybody knows that -4 creates the hole, but it's at -4 comma what? See, it's right there. Where exactly is that? Well, you're going to take the -4 and you're going to stick it back in the function, but you're not going to stick it back in the original function or it'll just crash. That's the whole point. So what do you stick it into, Tyler? If I can't put it in the original function, because it would just go into that blue part of the function and it would make a 0 on the bottom and there's no answer.
You would just put it into the red X.
This part of the function. Yes. And when I put the -4 in there, I get y equals 1 over -4, which is -1/4. And that's the coordinates of that spot right there. That make sense to you? All right. So that's how to find exactly where the hole is. Yeah, it was at -4, but -4 comma what? Okay. Next, there was the horizontals, and I said there was 3 rules because there's 3 types. This can be the case where it's bigger on the top. What would that look like? I have no idea. So how would I find out what it looks like? Well, I'd find its asymptotes first. And this one's bigger on the top. And I also know it's got a 0 on the bottom, like something makes the bottom 0. But that might be a hole, but wait, no, can I cancel that x? No, I can't. So many little things you have to know. You can't cancel that x because the x squared on the top is part of an add problem. So I can't cancel those x's. So if this is bigger on the top, that causes one kind of asymptote. So everybody figure out what this asymptote would be. And then what if it's bigger on the bottom? And that's where it would be like x over x to the third plus 17x. Doesn't really matter. And last but not least, same on both. Like y equals 3x squared over x plus 2 and x minus 5. And think about that. If you multiplied them out, it would be the same on both, same degree on both. So what are the equations for these? Well, they're horizontal asymptotes. So horizontal asymptotes, y equals things. They all are y equals things. Okay, figure out the 3 answers for those 3 problems, and I'll pause for a second while you figure that out. All right, please compare with the kid next to you and see what they have for these 3 asymptotes. Okay, bigger on top, there's no bots. Okay, it's a dumb way to remember it, but right now there's no bots. There will be bots. There'll be bots delivering you food soon. There'll be bots cleaning your house. There'll be bots that you hire to work in your company. I know it sounds crazy, but it's coming. But there's no bots if it's bigger on the top. If it's bigger on the bottom, then it's Bob is a 0. That's the way I remember it. Unless, do you get if I had put a +7 out here, the whole thing would have had to move up 7? Think about it. Then the horizontal asymptote would have had to move up 7 with it. So Bob's an outsider plus whatever's on the Bob's a 0 plus whatever's on the outside. So there was nothing on the outside of the fraction. And so it's just 0. Okay? So again, if I had put this in parentheses and then said, oh, -3, the whole thing would have moved down 3. Okay? That's a bigger on the bottom. And last but not least is a sob. Those will make you sob because they're the hardest ones, but they really aren't that hard. It's just a ratio of what? The leading coefficient. So what's the answer here? 3 over 1, which is 3. You got it. Okay. Would this one also have had some vertical asymptotes? Yeah. Would you please write down what are the VAs for this last one? You can have lots of vertical asymptotes. Your function can have like 5. You can have unlimited, actually. Whatever makes the denominator 0. Aman, tell me the 2 verticals.
Is it -2?
Yep.
And 5.
That's all there is to it. Those 2 spots, they make the bottom 0. Function can't exist there. And if the function can't exist, there's 2 ways that can happen. They can either be asymptotes or holes. But there was nothing on the top to cancel to make it a hole, so they're asymptotes. All right, so that's vertical, horizontal. That's about holes. And is there anything else? Yeah, just plain old, like finding a few points on the graph. Because why? Because imagine you figured out the asymptotes are here and here, and then you know there's a point right here and a point right there. Well, then, could you complete the graph? I could. All you need to do is find something on each side of your vertical asymptote. Because now I can go, oh, probably going to go like this. Are there weird exceptions? Yeah, and if I was on a test, I'd probably want more than just 2 points. Because there are times, you learned yesterday, that you can cross the horizontal asymptote. So, but that's really rare, and you'll never cross a vertical asymptote, at least in the high school level. Maybe there's a way that I don't know about. I'm just willing to admit I don't know. Because you used to think, when I was your age, that, oh, it's asymptotes, you should never cross the asymptotes. Well, there's weird cases where you do. Okay, so what would a typical test question have also in it? A hole. What if there had been a hole right there? What would that have meant? Well, at this spot, let's say that this spot was like 8. Do you get that that would have meant that somewhere in this function, which could have had a lot of things in it, what would there have had to have been on the top and the bottom? X minus 8 on the top and the bottom. Make sense? All right. I feel like you're understanding this. I could be wrong. We are not doing the CAN lab this year, so that saves you a whole lab. Yay. I will tell you, we might do an activity about it because it was kind of cool. It boils down to, and in case we do that activity, which would not be a lab and therefore doesn't have to be all written up the same and everything. The thing is, do you get that cans, they don't just randomly pick how to shape the can? Think about it. If you're a big company you're going to factor in a few things when you make your can. Do you get that a teeny tiny pencil-shaped can could hold soup? Okay, there'd be some downsides to that. And it has to do with how much surface area you need to put in your certain volume of soup. So if you know ahead of time, okay, we want to give them about 2 cups of soup. Well, then there's a lot of ways you could shape the can. And so how do you decide how to shape the can? And so it's kind of an interesting lab, but we're not doing it right now. So please move on to this one. I would like you to find out, one thing we haven't been talking about much is the domain. I want to take a minute to clean that up now. The domain is all real numbers except whatever crashes the function. Do holes crash the function? Yeah, so you got to take those out of your domain. Remember, domain's what you can safely feed the function. Can you feed it something that is a hole? No, because it doesn't exist there. And can you feed it something that makes the bottom 0? No. So really you just have to watch for the things that make the bottom 0, because it doesn't even matter whether they're holes or whether they're vertical asymptotes, because either way, they're not in the domain. So the domain here would be all reals, and I'm going to accept this shorthand for this. All reals except x cannot be 3, and what's the other thing x cannot be on this one? Yeah. Now, what's another way you could write that? Well, if you wanted to, you could use number line notation. That's pretty fast. Here's -1, and here's 3, and it can't be this and it can't be that, but it can be everything else. That number line notation is an accepted way to write the domain. Or you could write the longest one, which is -infinity to -1 union, -1 to 3 union 3 to infinity. I think you know what I mean. There's 3 different ways you could write. Okay. Would you please try these 2 questions that I said say practice? By now, you should be able to do these. You should be able to get these answers. Notice I'm not asking you to graph them. If I did, all you'd have to do is make an XY chart, throw on a couple points with the asymptotes. But we're not graphing these. All right, try these 2. I know it's going to take a little bit, but this is it. This is the main thing. If you don't get this, we shouldn't even move on, because this is the crucial stuff. Half of your next test is based on this stuff. I'm going to pause for a second. Let me give that a try. You have time. All right, so here we go. The domain is, I'm going to make a number line and say it can't be -1 and it can't be 3. Empty spot, empty spot. Use a different color to fill it in. There, there, and there. Okay. The vertical asymptotes. Well, I got to know if this thing factors, because otherwise these things down here are either asymptotes or they're holes. And so if I get this thing factored, I'll know if anything canceled and made a hole. And it's x, and then how do I factor that again? Well, I got to make it multiply to a 9. Well, that's probably a 9 and a 1, given that I want an 8 in the middle. And the 8's negative, so I want the bigger number to be negative. So I'm going to go like that. And yeah, I got it factored. Oh, and there was a hole. Look at that. That one and that one cancel and make a hole at -1. But were you smart enough to remember that you have to get the rest of the hole? If all you said was -1, you missed something I taught earlier this hour. So take a second and go back and figure out the rest of that while I give the rest of the answers. The vertical asymptotes, those come from what makes the bottom 0. Well, there's 2 things that make the bottom 0, but that one was a hole. So then the only thing left is this one, and that one's going to be x equals 3. And is that the right letter for this? It's very common for kids to say y equals 3, so they're not sure. The verticals are the zerticals, and the horizontals are the horizontals. It's dumb, but it might help you remember which one's which. Okay, the horizontal asymptotes, I often say, ask Bob. Is it bigger on the bottom, bigger on the top, or same on both? Well, it looks to be the same on both. If you're looking at the degree, they both have a degree of 2. That one's a degree of 2, and the bottom one, if I multiplied it out, would have degree 2. They're the same on both. What's the rule for SOBs? It's ratio of lead coefficients, 1/3. And now I've given you some time that this thing factored to x plus 1 and x minus 9, and then this canceled. So this is the part that's left. That is what you put the negative 1 into. That, and now I have negative 10 over, let me think, if I'm putting a negative 1 in here, that's negative 4 times 3 is negative 12. Oh, the negatives are going to cancel. 10 twelfths. 5/6. Raise your hand if you had 5/6. That's a lot of people. Yay. Okay, cool. That's how you do that one. Now, let's see. I'm going to ask for Isaac. Can you please read me the answers for this next one?
For the domain, I got all real numbers, x is not equal to 0 or 5. And for the vertical asymptote, I'm not sure if I got it right, but I got 0 and 5. And for
Just to clarify, what letter is 0? What letter is 5?
like letter,
Like vertical asymptote, if you just say 0, you're wrong. Got to say x equals or y equals, and which one is it?
x equals,
Yep, zerticals. X equals 0, x equals 5, and then you're right. Okay, how about the horizontals?
0,
Because why?
because the bottom degree is bigger than the top one.
So if it's a bob, then it's just y equals 0, unless there's something on the outside, but there wasn't. So it's y equals 0. What if there'd been a plus 9 out here? What would you have done?
Y would equal 9.
Okay, good. Y would equal 9 then. So then, let's do this last one. Holes.
I could not find any.
You are correct. It is none, because nothing canceled on the top and the bottom. Okay. Yes.
For the first one, how is it 5/6? Because I got 5/2.
Did you see how I got 10 twelfths? You're talking about this second part of the hole?
Yeah.
Okay. So where did you put the negative 1?
In negative 1 x and then in the x and x minus 9 and the x of x minus 3.
Would you agree that on the top we have negative 1 minus 9? Okay. What do you think we have on the bottom?
Negative 1 minus 3.
Oh, you're just forgetting this 3 in the front.
Oh, thank you.
Yeah, no problem. Okay. Any other parts? Okay. So the only thing I can see that you really didn't have to do there was, they're talking about making a sign diagram. That's if you said it's less than 0, for example. So, all right, I'll show you how that was going to work. This is just reminding you how to find the steps to actually graph these things. We've been doing that since day 1, which makes it easier. And the biggest thing that I want you to do is graph points. I'm not so worried about using a sign diagram. I'm more just saying find more points. If you had to graph this, I know it looks kind of crazy, but that involves a slant asymptote. You see how that purple one here, I'm going to draw over it with red. This one right here, do you get that that asymptote would normally be horizontal, but it's slanting? That's weird. Okay, so in the past we have not tested on slant asymptotes, so that's not something that you have to worry about. But I'll just tell you this. If you had 1 over x, and that was a normal one, and then I said, oh, but what if you add 3 out here? Then you remember how the asymptote would go from, it's a bob, so it would go to y equals 0, but then there's something on the outside, so y equals 3, okay? What if it had been 3x? Then what would the asymptote have been? It would have been a slanted asymptote. Okay, so here's one where we actually need to graph it, and I will tell you it's exactly like what we just did. There's nothing new here, except you have to make an XY chart and find a few points. What's one point that won't exist? Yes?
-2.
-2. If it's okay to put that on your chart, but then you just go, Oh, yeah. Does that make an asymptote or a hole in this case? It's what makes the bottom 0, so it makes a vertical asymptote. And any other number you put in, it's going to give you a few points. All right, so I would not start with points. I would start with the asymptotes. So I'd always figure out, it says find the domain. Actually, you don't need to find the domain to do the graph. It's not a bad idea to know the domain, but it's just going to remind you that -2 is a thing. Okay, next. I mean, it's a thing as in it's going to be an issue. You have to have an asymptote there. Yes, you should simplify it. Then you should find the x and the y intercepts of them. I agree with that because they're super easy points to find. They're just points. Finish this sentence. The x-intercept is where what? Y equals 0. So you just say this is 0. Can I find a way to make this equal 0? Actually, you can't. This is weird. How can I not make something equal 0? Because if there's a 4 on top there, think about what you could divide by to make it equal 0. Maybe you've never noticed this before. You can't make that 0. There's no way to make that equation equal 0. What does that mean? There's no x-intercept or no y-intercept? No x-intercept, because y equals 0 is impossible. There's no x-intercepts? Correct. No x-intercepts. Why? Because I tried to make y equal 0 and there was no way. If you have a plain old number on top of a fraction, there's no way to make that equal 0 by changing the bottom. Okay? All right. So this one doesn't have a y-intercept. No, wait. It doesn't have an x-intercept. But it does have a y-intercept. I would do that by setting the y-intercept is where x equals 0, right? So I'd put a 0 here, and then I'd find and just put it on my chart. All right, so let's put in 0, everybody. Did you get 4 over 2, which is 2? 0, comma 2. Is 2 points enough? Next, I do want to find where the asymptotes are, because 2 points might be enough. Actually, this isn't a point, though. That's just an asymptote. All right. So, location of any vertical asymptote or holes in the graph. There weren't any holes here because nothing canceled, but there is a vertical asymptote. Is there a horizontal asymptote? You'd have to know the Bob rules. All right, so figure out the vertical asymptote, figure out the horizontal asymptote. Then find a few more points. I've only got one. Then graph it right there, and I'll pause while you give that a try. So we've got our vertical asymptote in there, our y-intercept at 2. Didn't have any x-intercept, so that's interesting. Did it have any horizontal asymptote? At 0. Why do you know that? What are the rules on the horizontals that told you that? So if it's a bigger on the bottom, what's the rule for a bob? Bobs are y equals 0. Okay, so this one has a y equals 0 asymptote right there. Okay, now your next goal is to get another point, because if I actually kind of know it's going to look like this. I'm not absolutely positive, but I'm pretty sure. Ruby, tell me how I can get another point to be able to finish my graph. Okay, and which x's should I pick to stick in my xy chart? Positive 1, we can do that. I'll put in a 1. And then I have 4 over 3 over 1 up 4/3. And that's, okay, I guess it went a little lower than I thought, so I'm going to adjust my graph. But it's still kind of heading the way I thought it was gonna. But wouldn't it be smart to pick something over here so that I can see where it is on that side of the vertical? So give me a number that we can stick in that's in that little circle. Okay, -4 seems logical. So then I put in a -4 here, and I got 4 over -2, which makes -2. 4, -2. All right, so that's over 4 wait a minute, negative 4, negative 2, sorry. So negative 4, negative 2. Well, look at that. That makes me think it's probably just going to do this. And there we go. Raise your hand if you had that one right. Cool. What if there had been a hole? Do you get it? Would have been really easy to forget that. Always check. I'm warning you on your graphs. Always check. Was there supposed to be a hole? You know, look back because it's so easy to forget that. And then you're going to lose at minimum, you lose 5%. Okay. On. So I want to just say graph it. And I think you can without any extra help from me. Okay, so I'm just going to be quiet. Everybody try graphing this one.
Function on the top.
I like it. If you can factor it, you should. What did you get on the top?
X minus 3 times 20
X
x plus 2.
plus 2?
Yes.
All right, excellent. Did you notice that nothing canceled?
Yeah.
Then what are all the things that make the bottom 0 called?
Vertical asymptote.
And what are all the things that make the top 0?
The x-intercept.
Those are the x-intercepts. Yes, so 3 and negative 2 are x-intercepts. Is that important? Yeah, because those are points that are really valuable points. They go on the XY chart. Okay, Tyler, take back over again.
From there we can just graph some points.
Okay, like the x-intercepts maybe.
Yeah.
So the x-intercepts are where y equals 0. So then the 0 equals, so how do you make this equal 0?
We're putting in a 3 or a negative 2.
And I already know the answer. It'll make it 0. Cool. So 3 comma 0, negative 2 comma 0. Awesome. What else should I do?
You can make the dotted line.
All right, the vertical asymptote is at?
X equals negative 1.
Is there a horizontal asymptote?
No,
Why not?
because the degree is bigger on the top.
It's bigger on the top. And you knew the rules that there's no bots. The bigger on top kind, there's no asymptotes there. So there's no horizontal asymptotes. So how am I supposed to know where this graph's going to go? I need more points. Jack P., give me another point.
I had 1, negative 3.
All right, so if I put in a 1, I'm just going to check you here. I'd get negative 2 times 3 is negative 6. Negative 6 divided by 2 is negative 3. 1, negative 3. He's right. I go over 1. I go down 3. There's another point right there. Oh, that helps. I'd like some more points. Got another one?
Oh yeah, the y-intercept is 0, negative 6.
Hold on. I just graphed something wrong then. Sorry, I put that in the wrong spot. 1, negative 3 is right there. Okay, 0, negative 6, did you say?
Yep.
1, 2, 3, 4, 5, 6. Okay. You know what that looks like it's doing to me? It looks like it's getting closer and closer to the asymptote this way. And then it probably swings away. But I don't know for sure unless I try a few more points. So bottom line, get points. It'll really help. The more points you have, the better you do. I'm going to make all my points black here just to make it clear where the points were. I knew about that point, so all those 4 black points I've found so far. You find a few more points? Jack T, give me another point that uses a negative x.
I didn't get one. You put negative.
Let's just do one together right now.
Negative 2, negative 3.
Negative 3. All right, so let's put in negative 3. It's going to go here and here and here. And I'll get negative 3 minus 3 is negative 6 times 3 over negative 3 plus 1 is negative 2. So the negatives will cancel. And it'd be 18 divided by 2 is 9. Do you concur? All right. 9. 3 comma 9. Negative 3 comma 9, sorry. 1, 2, 3 comma 9. 1, 2. Oh, it's way up there. but it's getting further from the asymptote. Uh-oh. Got people looking at the screen funny. There's a chance that that's messed up. Can you tell me if there's a mistake there? Did anybody else get negative 3.9? You're not talking, but you're...
I got -3, -3.
Okay, so then there may be something wrong with the negative 3 we put in there.
Yeah, that sounds about
What?
Yeah, it's negative.
You got negative 3 comma what?
-3.
All right, so let me see what I did wrong there. Negative 3 minus 3 is negative 6. That was right. Times, oh, I see what I did wrong. Negative 3 plus 2 is negative 1. That's where I messed up right there. All over negative 2. And that does not equal 9. It equals what? Negative 3. All right, so clean that off. All right. Now, again, I don't know what this looks like. I'd love it if I just kind of knew naturally what it looks like, but I don't know. Now, I could find it though if it give me enough dots. Let's just do one more. Did anybody put in negative 4? Help me. What'd you get?
For -4, it was like, yeah, 14 thirds.
14 thirds? Somebody,
14 thirds.
could somebody verify negative 14 thirds? Okay, quite a few people got that. Good. So I'm going to just kind of simplify that a little bit to see what would it be about. So I'm going to say it's negative 4 times 3 is 12. So negative 4, that'd be 12, and then there's 2 left. Negative 4 and 2/3. Okay. So negative 4, comma, 4 and 2/3. Negative 4. All right. I can tell that that one, with 3 points, now I can be pretty confident that that thing's going to go like this and get closer and closer that way. Cool. You get how it comes down to making a lot of points and finding asymptotes. That's really what the graphing thing is. All right. I strongly recommend doing several graphs as your homework. You have to do all of them? Of course not. Don't do any of them, then you're going to be in rough shape on Monday. That's all I got for you for today.